Hello. A railway engine is traveling along a horizontal track at a constant velocity. A. On the diagram above, draw a labeled arrow to represent vertical forces that act on a railway engine. The question only asking the vertical forces. So the first one is the weight, downward direction, and normal reaction force from the two wheels. R. And that's all. I think that's all. Explain with reference to Newton's law of motion why the velocity of the railway engine is constant. The horizontal force have a resultant of 0. In this case, the engine force minus the friction equals to 0. And we know from Newton's second law, net force equals to mass times acceleration. As the net force equals to 0, then the acceleration equals to 0, and this results in constant velocity. So constant horizontal velocity of railway engine is 16 meters per second. A total horizontal resistive force of 76 kilonewton acts on a railway engine. Calculate the useful power output of the railway engine. As we know, it has a constant horizontal velocity, which means the net force equals to 0. That means engine force minus the drag force equals to 0. Here drag force or resistive force is 76 kilonewton, which means the engine force also equals to 76 kilonewton. Output power, which is force times velocity, and force here is 76,000 and the velocity is 16. That gives us 1.2 times 10 to 6 watt. The power driving the railway engine is switched off. The railway engine stops from its speed of 16 meters per second without braking in a distance of 1.1 kilometer. A student hypothesizes that the horizontal resistive force is constant. Based on this hypothesis, calculate the mass of the railway engine. Let's use method number 1, which is very straightforward. Work energy theorem. That is, work done equals to change in kinetic energy. And work done is force times the distance in the direction of the force equals to final kinetic energy minus initial kinetic energy. Force times the distance in the direction of the force is F times S times cosine theta equals to final kinetic energy. In this case, the railway engine stops, so final kinetic energy equals to 0 minus initial kinetic energy 1 over 2 mu squared. The resistive force is 76,000 times the distance traveled 1100 times cosine 180 degree. Why cosine 180 degree? Right, distance traveled is move forward, but resistive force is opposite direction. So distance traveled and force, resistive force is anti-parallel. So that's cosine 180 degree, which gives us minus 1. Minus 1 over 2 times mass times initial velocity 16. And that gives us 2 times 76,000 times 1100 divided by 16 squared. That gives us 6.5 times 10 to 5 kilogram. So method 2, we probably use kinematics equation. We don't know the time. Let's use timeless formula. Final velocity squared equals to initial velocity squared plus 2 times acceleration times the displacement. Finally, the railway engine stops, right? So as the engine is switched off, so final velocity squared, which is 0 squared equals to initial velocity is 16, so 16 squared plus 2 times acceleration times the displacement is 1100. So acceleration equals to minus 16 squared divided by 2 times 1100. That is minus 0.116 meter per second. As we know, net force equals to mass times acceleration, and here the net force is the resistive force. So mass equals 2 net force, which is resistive force, divided by acceleration. And resistive force is 76,000 divided by deceleration 0.116, and the mass is 6.5 times 10 to 5 kilogram, same as before. Another hypothesis is that horizontal force in C consists of two components. One component is constant frictional force of 19 kilonewton. The other component is a resistive force F that varies with a speed v, where F is proportional to v cubed. State the value of magnitude of F when the railway engine is traveling at 16 meters per second. Horizontal force in C consists of two components. So that is frictional force plus the resistive force. And the horizontal force is in C equals to 76 kilonewton. And frictional force is 19 kilonewton. That means the resistive force equals to 76 minus 19, which is 57 kilonewton. II determines the total horizontal resistive force when the railway engine is traveling at 8 meters per second. Resistive force is proportional to v cubed, which can be written as resistive force equals to kv cubed, and k is constant. We can actually find k first. K equals 2 F divided by v cubed, and from previous question we know the resistive force is 57,000 and velocity is 16. That gives us a k, which is 13.91, and we plug into resistive force equal to k times v cubed. In this case, the velocity is 8, so k is 13.91 times velocity is now 8 cubed. That gives us 7,100 newton. Now the total force, total horizontal force equals to frictional force plus the resistive force. Frictional force is still same, 19,000, and plus resistive force is 7,100. That gives us 26,000 newton or 26 kilonewton.